252 million years ago, our world was plunged into a planetary fever. It was a catastrophe not of sudden impact, but of slow, inexorable suffocation. In the oceans, a silence fell as 90% of all species vanished. On land, 70% of life was extinguished. The last of the trilobites, rulers of the Paleozoic seas, were gone forever. The giant amphibians, lords of the swamps, breathed their last. An entire chapter of Earth's history was brutally erased. This was not the work of an asteroid. This was not a slow slide into an ice age. This was a wound, opened deep within the planet's core. In the heart of modern-day Siberia, the Earth's crust split apart, unleashing a sea of fire that would flow for 500,000 years. These were the Siberian Traps, a volcanic province that would ultimately bury a region larger than Europe under kilometers of basalt. Before the Inferno, the Permian period was a world of vibrant, alien splendor. 300 million years ago, the climate was stable, the planet breathing in a steady rhythm. Herds of armored parasaurs, living fortresses the size of cattle, browsed on ferns in groups of 10 to 15. They were prey for the gorgonopsids, saber-toothed predators that were not reptiles, but synapsids, the ancient lineage from which all mammals, including ourselves, would eventually arise. Evolution was proceeding as planned. The diapsids had appeared, the ancestral line that would one day give rise to dinosaurs, crocodiles, and birds. Giant dragonflies with wingspans of 70 centimeters patrolled the skies. But beneath this thriving ecosystem, a geological time bomb was ticking. The continents were grinding together, coalescing into the single immense landmass of Pangaea. This colossal merger rained currents. Then, the fire began. The Siberian eruptions pumped trillions of tons of carbon dioxide and methane into the atmosphere, triggering a runaway greenhouse effect. The planet warmed, and the oceans, absorbing the excess carbon, turned acidic. The very water became a corrosive soup, dissolving the shells and skeletons of countless marine creatures. On land, the poisoned air grew thin, and insects, once masters of the air, suffocated in an atmosphere starved of oxygen. Life was dying on a scale that defies imagination. Yet, in the crucible of this global disaster, a few hardy survivors clung to existence. From the ashes of the Permian world, a new one would be born. A world ruled not by our distant kin, but by the descendants of the diapsids. The Great Dying had cleared the stage for the age of dinosaurs. Life, it seems, does not merely endure annihilation. It uses the blank slate of extinction to write its next, and perhaps most spectacular chapter. Far out at sea, the ancient, life-giving. Far out at sea, the ancient, life-giving ocean currents falter, their familiar paths twisting into new and unpredictable patterns. The world's heat is being redistributed. The climate, once stable, is fracturing into violent extremes. Winters of profound cold, summers of blistering heat. A great thirst settles over the land as the humidity plummets. But these are merely symptoms. The true cause lies not on the surface, but in the planet's deepest heart. Deep beneath the crust, the slow, inexorable collision of continents is awakening a primordial power. Tectonic stresses build along ancient fault lines, creating a network of fractures that penetrate miles into the rock. Magma, under unimaginable pressure, begins to stir. The world is preparing for a volcanic event without precedent, an eruption that will redefine the very meaning of catastrophe. 252 million years ago, beneath the land we now call Siberia, the planetary clock ran out. From the molten depths of the mantle, a superplume, a gigantic ascending torrent of incandescent rock, began its journey. Its temperature exceeded 1,000 degrees Celsius. Its volume was measured in millions of cubic kilometers. This pillar of fire punched upward, weakening the crust above it until, finally, it burned through entirely. This was the birth of what geology has named the Siberian Traps. The name is deceptively mundane, derived from the Swedish word for stairs, because the cooling lava formed vast, stepped plateaus. Yet the scale of this event has nothing in common with the cone-shaped volcanoes of human experience. This was not an eruption. It was a wound in the world. Imagine an area of 2 million square kilometers, a territory larger than all of Western Europe, simultaneously tearing open. Lava did not erupt from a single crater, but bled from more than 1,300 fissures, some stretching for dozens of kilometers. It was a flood of fire. Rivers of molten rock poured across the landscape, filling valleys, incinerating primeval forests, and boiling entire river systems into steam. In places, the accumulating layers of basalt would reach a staggering thickness of 4 kilometers. For a period of time still debated by scientists, somewhere between 100,000 and a million years, the planet bled. Even at the shortest estimate, 100 millennia of continuous eruption is, in geological terms, a mere instant. The volume of magma unleashed is almost beyond comprehension, between 1 and 5 million cubic kilometers. For comparison, the cataclysmic 1883 eruption of Krakatoa, one of the most violent in recorded history, ejected just 20 cubic kilometers of material. The Siberian Traps unleashed 250,000 times more, but the lava was only the physical manifestation of the apocalypse. The true killer was invisible. With the fire came the gases, released in millions of tons each day. Carbon dioxide, sulfur dioxide, methane, hydrogen chloride. The atmosphere was being systematically poisoned. Carbon dioxide by itself is not a toxin, but its concentration in the air skyrocketed by a factor of 13, soaring from a stable 300 parts per million to nearly 4,000. A runaway greenhouse effect was ignited. The planet developed a fever. First, global temperatures rose by a few degrees, then by 5, then by 10, and ultimately by as much as 12 degrees Celsius. The global climate system collapsed. The equatorial zones, once lush, became sterile deserts where surface temperatures reached 50 or 60 degrees. The great forests died, unable to withstand the suffocating heat. And as the plants withered, the architecture of life crumbled. With no producers, the herbivores starved. With no proof, methane, a gas 25 times more potent as a greenhouse agent than carbon dioxide, made a dire situation infinitely worse. As the magma surged toward the surface, it tore through massive coal seams laid down during the Carboniferous period. These immense deposits of ancient carbon were ignited, vaporized, and injected directly into the sky, adding colossal quantities of both carbon dioxide and methane to the already toxic air. It was the planet turning its own life-filled past into the fuel for its future extinction. The world was choking on its own breath, buried under a funeral shroud of basalt, as the greatest dying in the history of life began. From the abyssal depths, a silent executioner began to stir. On the ocean floor, vast, frozen reserves of methane hydrates, cages of ice imprisoning immense volumes of the potent greenhouse gas, were growing unstable. As the world's waters warmed, these cages unlocked. Methane, once trapped for millennia, began to bubble upwards, breaching the surface and entering the atmosphere. Each released molecule accelerated the warming, which in turn melted more hydrates on the seabed. It was a positive feedback loop, a planetary fever spiraling into a self-accelerating cycle of destruction. Simultaneously, the land itself was tearing apart. Colossal volcanic eruptions convulsed the planet, belching sulfur dioxide into the heavens. This gas reacted with atmospheric water, birthing clouds of forests, poisoning the soil, and sluicing into rivers and seas. The oceans, the cradle of life, began to turn corrosive, The pH plummeted. For countless organisms that built their homes from calcium carbonate, this was a death sentence. Their shells and skeletons, the very architecture of their bodies, could no longer form. In the acidic water, they simply dissolved. As if this chemical assault were not enough, another volcanic poison, hydrogen chloride, tore at the planet's protective shield. The ozone layer, which filters the sun's most lethal energies, began to disintegrate. Unchecked ultraviolet radiation flooded the surface, searing the world, inducing mutations, and delivering fatal doses to exposed life. But perhaps the most insidious killer was not what was added to the world, but what was taken away. The very air was thinning. The level of oxygen in the atmosphere began a catastrophic decline. The causes were numerous, a conspiracy of fire and chemistry. Continents ablaze, infernos sparked by lightning and flowing lava, consumed oxygen by the gigaton. Burning seams of coal, exposed by the surging magma, drew down yet more. The methane rising from the seas oxidized in the atmosphere, binding with oxygen atoms and removing them from the breathable mix. And with the planet's flora dying from the heat and acid rain, the great green engines of photosynthesis sputtered and fell silent. New oxygen was no longer being produced. Over several 100,000 years, the oxygen content of the air plummeted from a robust 21% to a suffocating 15%, perhaps even 12%. For either satisfies. For the fauna of the Permian period, it was a disaster, especially for the insects. The insect respiratory system, a network of tubes called tracheae that permeate the body, depends directly on the ambient concentration of oxygen. The less there is, the less efficient this passive system becomes. Larger insects, with their greater metabolic demands, were the first to suffer. Their tracheae simply could not deliver enough oxygen to sustain their bodies. The giant dragonflies of the earlier Carboniferous period, titans of the air with wingspans of nearly a meter, had thrived in an atmosphere rich with 35% oxygen. By the Permian, as levels dropped to 21%, they had already shrunk. But when the concentration fell toward 15%, their world ended. 80% of all insect genera vanished in a geological instant. Only the small, the unassuming, could survive in the thinning air. This brutal principle held true for all life. It is far easier to supply oxygen to a small body than a large one. Planetary scale. Those that survived were those that had shrunk. Evolution's course was violently redirected. Survival no longer favored the strongest, but the smallest. Yet the true apocalypse was unfolding beneath the waves. Sulfur, washing into the deadened seas, was feasted upon by anaerobic bacteria. Their waste product was hydrogen sulfide, a lethal poison that stripped the water of its remaining oxygen, creating a global anoxic event. The oceans were turning into a stagnant, lifeless tomb, choked by a toxic gas that suffocated any creature that breathed water. The fish died. The plankton, the very foundation of the marine food web, perished. And when the plankton died, everything that fed upon it starved. The entire ecological pyramid collapsed from the bottom up. It was a mass death of unimaginable scale. 90% of all marine species were erased. The trilobites, resilient survivors of 270 million years and 4 previous mass extinctions, finally met an enemy they could not endure. Every last one disappeared forever. The ammonites, with their beautiful spiral shells, were decimated, pushed to the absolute brink of oblivion. The Great Dying was not a singular event, but a cascade of planetary failures, each one compounding the last. It stands as a chilling testament that the intricate web of life, woven over eons, can be unraveled by the very chemistry of the world that sustains it. From the ashes of a global fire, only a handful of species would survive to begin the long, arduous work of restoration. In the oceans, where life had flourished in unimaginable diversity, the silence fell first. The world's vast coral reefs, architects of underwater kingdoms for millions of years, were bleached into barren graveyards. The brachiopods, shelled creatures that had dominated the Paleozoic seafloor, lost 95% of their kind. The very chemistry of the sea had turned against its children. As the waters grew acidic, they became a corrosive solvent, dissolving the protective armor of countless organisms. There was no longer a way to build a defense. Anoxia crept from the depths, a suffocating blanket that left no room to breathe. Lethal temperatures soared, and from the stagnant abyss, clouds of toxic hydrogen sulfide rose, poisoning everything they touched. The vibrant ocean, the cradle of life, had become a putrid chemical broth. On the supercontinent of Pangaea, the situation was only marginally better. The extinction on land was a slower, more creeping dread, but it was just as inexorable. In the end, 70% of all terrestrial vertebrate species would disappear. The great amphibians, rulers of the swamps and riverbanks, were almost entirely erased. The temnospondyls, giant predatory amphibians stretching 3 meters in length, vanished forever. Gone. The gorgonopsians, saber-toothed, gone. The gorgonopsians, saber-toothed apex predators of their age, were hunted not by a rival, but by the world itself, into oblivion. The dicynodonts, massive, tusked herbivores with beaks instead of teeth, were nearly all annihilated. Survival became a game of inches. Only the smallest, the most resilient, the most adaptable were spared. The climate was changing faster than evolution could keep pace. Landscapes warped. Lush forests withered into scorched desert. Rivers ran dry, and entire habitats simply ceased to exist. With their foundations shattered, the intricate food chains collapsed into dust. Starvation became the new law of the land. Animals attempted to migrate, to flee the rising heat and the spreading desolation. But on the single landmass of Pangaea, there was nowhere to go. The continental interior was an impassable furnace, a desert of killing heat. The coastlines, the last refuges, became overcrowded with desperate climate refugees, triggering ferocious competition for dwindling resources. This was not a selective event. It was an indiscriminate apocalypse. It claimed the large and the small, the predator and the prey, the swift and the slow. The specialists, organisms finely tuned to a specific way of life, were the first to perish, their worlds vanishing from beneath them. The generalists, those able to scrape by on whatever they could find, held on longer, but they too were decimated. The planet was left empty. A staggering 83% of all genera of living things were wiped from existence. Not species, genera. Entire branches of the tree of life hacked away in a geologic instant. Ecosystems built over eons were left in ruins. The biosphere itself had been pushed to the very brink of total collapse. History has no parallel. This was the most profound mass extinction the Earth has ever known. Nothing, before or since, has come close. The cataclysm that ended the reign of the dinosaurs 66 million years ago seems a lesser tragedy by comparison. That event claimed 75% of species. The Permian extinction claimed over 90%. It was a purge of life on a scale that defies imagination. Scientists have a name for it: the Great Dying. It was the moment life on Earth nearly went out for good to recover. For the first 10 million years of the ensuing Triassic period, Earth was a ghost planet. In this hollowed-out world, The few survivors crept out to populate the empty niches. Evolution, working on the ragged remnants of the old world, began its slow and painful work of creation anew. Among the survivors was a creature called Lystrosaurus, a small, pig-sized dicynodont with a short face, a horny beak, and powerful digging limbs with few competitors. It endured the catastrophe because it could burrow deep into the earth, sheltering from the heat, and because it could eat almost any tough vegetation it found. And alongside it, a few species of cynodonts also survived. Snarled, a new destiny would eventually arise. From the greatest death, life found a way. Not just to recover, but to be reborn into forms the old world could never have conceived, setting a stage 200 million years in the future for a species that would one day look back and wonder how anything survived at all. From the ashes of a world scoured by fire and choked by poison, life began its slow, tentative return. The Permian-Triassic extinction, the Great Dying, had torn the tapestry of existence to shreds, leaving a ghost planet in its wake. Yet, in the shadows of this global cataclysm, survivors stirred. Among them were the archosaurs, primitive reptiles, ancestors to both dinosaurs and crocodiles. They were not titans, they were small, inconspicuous creatures, but they possessed a resilience forged in the crucible of the apocalypse. The oceans, once teeming with complexity, were now silent seas. Only a handful of ammonite species had weathered the storm. From these few, lonely lineages, a dynasty would be reborn. But recovery was not swift. For tens of millions of years, these cephalopods would slowly, painstakingly, reclaim the waters, their coiled shells eventually filling the marine void once more. A few species of fish, too, had clung to existence. Ancient sharks and hardy bony fish, the progenitors of the entire Mesozoic marine fauna. The very foundation of the food web, the plankton, recovered fastest. Within a few million years, the oceans bloomed again with algae and microscopic crustaceans, reigniting the engines of life beneath the waves. On land, the healing was measured in geological time. The great forests of the Paleozoic were gone, replaced by a monotonous, low-growing scrubland. For the first 10 million years of the new Triassic period, the Earth was a world of ferns, mosses, and primitive seed-bearing plants. The return of true forests would take tens of millions of years more. This was more than a recovery. It was a revolution. The Permian extinction had not just culled life, it had overthrown an empire. The old world had belonged to the synapsids, the dominant group of animals from which mammals would eventually arise. But the Great Dying broke their reign. The few synapsids who survived were driven to the margins of the world, becoming small, nocturnal creatures of the undergrowth. For the next 200 million years, they would live in the shadow of the new masters. Their time would come, but it was a distant dawn. The world now belonged to the archosaurs. Having survived the extinction, they stepped out of the shadows and into a world emptied of competitors. They seized the vacant ecological niches with breathtaking speed. Over the course of 20 million years, they diversified, grew, and established their dominance. 50 million years after the extinction, the first true dinosaurs would walk the Earth. The Mesozoic era, the age of reptiles, had begun. Pterosaurs would claim the skies, crocodiles the waterways, and dinosaurs the land. All of this was possible because their humble ancestors endured the Permian inferno. Why them? Why did the archosaurs thrive, while the dominant synapsids faltered? Perhaps it was a matter of superior adaptation. Some theories point to a revolutionary breathing apparatus, a system of air sacs akin to modern birds, allowing them to extract oxygen from the thin, anoxic air of the post-extinction world more efficiently. It would have been a profound advantage when the very atmosphere was hostile to life. Or perhaps it was simply the brutal calculus of luck. The right place at the right time. Evolution does not move with purpose. It is a dance with chance. A slight change in conditions, a different chain of volcanic eruptions, and the survivors might have been others. History could have been written by the descendants of synapsids, and the world of mammals might have begun 150 million years sooner. The Permian extinction serves as a terrifying reminder of the biosphere's fragility. A 10-degree shift in global temperature, fueled by volcanic cataclysms in what is now Siberia, murdered a world. A 5% drop in atmospheric oxygen was enough to collapse entire ecosystems. We, and every living thing on this planet, are the descendants of the few who survived. Our own ancestors, small cynodonts, hid in burrows from a sun that had become a tormentor, scavenging for scraps in a desolate landscape. Had they not endured, our story would have ended before it began. The evidence of this ancient apocalypse is not hidden. It is written in stone, across the vast Siberian traps. The Pudorana Plateau, the region of Norilsk. These are immense basaltic massifs, a sea of frozen lava that once bled from the planet's core and nearly sterilized it. Today, tourists stand on the edge of these cliffs, photographing a stark and beautiful landscape, unknowingly standing upon the tombstone of 90% of all life. The reign of the dinosaurs, therefore, was not born of strength alone. It was conceived in the stillness of a global grave. They rose to power not by conquering the old rulers, but by inheriting a world wiped clean, an empty stage waiting for new masters to appear. From the heart of the ancient supercontinent, a planetary wound bled fire for nearly 1 million years. The Siberian traps. An eruption so vast, it tore the veil between epochs, triggering the greatest extinction event the world has ever known. It was an apocalypse of unimaginable scale. The atmosphere, choked with volcanic gases, ignited a runaway greenhouse effect. The heat became suffocating. The rain that fell was not water, but acid, stripping the land bare and turning the oceans into a toxic soup. The very air grew thin, starved of oxygen, leaving life gasping in a dying world. Yet from this near-total annihilation, a new dynasty would rise. In the silence of the vacant earth, the age of reptiles began. Their subsequent reign, lasting for nearly 200 million years, was a dynasty born directly from the ashes of the Permian world. In turn, our own distant mammalian ancestors survived in the shadows of this empire, awaiting another cataclysm to grant them their own beginning. The Earth's history is not a gentle story. It is a saga of violent transformation, where endings are merely the brutal, necessary prologues to new life. Our own existence is owed to a fire that nearly extinguished the world.